So this is the 3D layout of the hydro power plant, and these are the parts of the hydro power plant. Here actually 4 bay is available. This is the 4 bay. 4 actually 4 head is nothing but forehead is nothing but initial first part of your head, nothing but forehead. Bay is nothing but path or place where the for example bus bay is nothing but the place where the bus can be stopped, or uh, that will be that can stop for a while, or that can be stay for a hours for a minute, or whatever it may be, whatever the place where bus can be stopped, that is called bus bay, nothing but place. So four way is nothing but that is a place for nothing but uh, in front of first part, the initial part of the reservoir, nothing but four part, nothing but four head part, nothing but four bay is nothing but the place where the water is stored. Four bay, nothing but in front of the dam, place is called four. Four bay is nothing but the water storage place, nothing but the place in front of the initial bay, in front of the dam, that is called behind the dam, this place is called four bay. Four bay is not shown in this diagram. The behind the dam, that is called storage reservoir, the water storage capacity is called reservoir, and small storage is called four bay. And this is surge tank, this is surge tank, and water hammer effect, water hammer water hammer effect. This is a problem which will take place in the hydro power plant. This can be overcome by using the surge tank. This is surge tank. So this surge tank is similar to the transformer, uh, transformer. So this surge tank is function is similar to this conservator tank in the transformer. So conservator tank, whatever the function of the conservator tank, that function of the conservator tank similar to the surge tank in the hydro power plant. So we'll discuss regarding to the surge tank later, how it will overcome the water hammer effect and what is the water hammer effect. And valve house, water valve house nothing but if you want to release the water to the turbine, so that can be controlled, nothing but water pressure can be controlled by using this valve house. And this is penstock, nothing but a pipe, and this is not a concrete pipe, this is a special steel pipe. And this is power house, in the power house and the turbine and generator will be coupled. And these are the main parts of the hydro power plant. And if you understand these power parts, you can understand uh, these terms in the further discussion. So these are the parts again we can recall. Forebay is a place near to the dam, and four is nothing but near to the dam, and bay is nothing but place where water stored. And intake structure is nothing but this is also near to the dam. Whatever the structure will be there, that is nothing but intake structure. And penstock is nothing but a pipe, and where the water can be released to the turbine from this pipe on a penstock. Water will be released from the dam to the turbine. Surge tank, I already discussed the surge tank. Water hammer effect, can be overcome by using the surge tank. And a turbine, you know very well. And powerhouse and draft tube. So draft tube is nothing but a draft tube will be like this actually. This is the penstock, and this is nothing but a draft tube. Draft tube will be like this. So water will be releases, and here turbine will be there. After turbine, the water will be releases to the draft tube. So this draft tube is designed in a special manner, special design. Nothing but by using this draft tube, water from the dam cannot be releases fastly, so that the water releasing this With this draft tube water will oppose the sudden releasing of the water. So that pressure, water pressure can be controlled by using the draft tube. And the tail raise, tail nothing but end, nothing but this is the ending part is nothing but a tail raise. So these are the parts of the idle power. So now let us discuss a power plant based on head, different types of power plants based on the head. So if you take low head power plants, this is head, this is total high head of the power plant, and this is a dam, and this is a catchment area of the dam. And you can see this one here, it is a simply a pipe is there, and there is no penstock in the low head power plants. Penstock is not used. Only a small directly water will be releases to the turbine. This is here turbine will be there. This is head race, and at the bottom is called that is called tail race. Whatever the water which is having head height, that is called head race, and the water after releasing the water will be reaches to the ground level. That water level is called tail race. Tail race. So, what are the importance of low head power plants? What are the factors? What are the important factors we need to remember? So, first one is this is a small dam which is constructed, which is built across the river, and uh, provides a necessary load. So, a small dam which constructed across the river. And the next one is the turbines are Francis Francis turbine or Kepler or propeller turbine. So, whatever Francis or Kepler, from both we can use any one. Next one is no surge tank is provided. So in this low head power plants, no surge tank is provided, and the height is less than 30 meters. The height of this low head power plant is less than 30 meters, and the production of electricity will be very less due to the low head. So if high head is nothing but high discharge of the water, and flow of water is high, huge, so that the rotation of the turbine also more, so that more electricity will be produced. If the head is low, the speed of the water releasing is very less, so that the production of electricity also less. Next one is look at this one. This is a medium head power plant. So in the medium head power plant, you can see here this is water from the main reservoir. This is the reservoir, and here head race and also forebay is available. So this is a forebay already discussed. Forebay is a place where the water releases to the penstock, and here the water is stored here. By using this forebay, water regulation, water regulation will be controlled. Nothing but like voltage regulation, water regulation also available. Nothing but the water regulation is nothing but sudden increasing water, sudden decreasing of water, or changing of water. Such a problems can be overcome by using the this forebay. So forebay maintains constant water releasing through the pipes, penstock. So from when compared to the low head power plants, here new term is forebay is available here. Forebay is available here, and also penstock is there. Penstock is also available. So two extra when compared to the two extra parts will be there in the medium head power plants when compared to low head power plants. So, what are the importance terms? What are the importance points remember to be remembered for medium head? So, mainly forebay is used, and forebay is placed before the penstock. So, that is we can observe by using the diagram. And water is carried through main reservoir to forebay. So, water from main reservoir to forebay and then to penstock. That is a process. That is a steps involved to flow the water into the to the penstock. And forebay act as a surge tank. Here, there is no surge tank. You can see here in the diagram. Uh, if you observe the diagram, there is no surge tank here. In the middle power plant, there is no surge tank here. So there is no surge tank. That's why this forebay. So the forebay which is available in the medium head power plant, that forebay act as a surge tank. And here the turbine is Francis turbine. So medium head, remember medium head Francis turbine, low head either Kaplan or Francis. Mostly Kaplan is be used. For high head, Pelton wheel, Pelton wheel turbine used. So Kaplan, Francis, and Captain Pelton wheel. So these are the points to be remembered for medium head power plants. And look at the high head power plants. And here reservoir, and this is four-way, and this is a tunnel. Separate tunnel will be there, and from this tunnel to four penstock is available. Penstock, and this is surge tank. This is surge tank. By using the surge tank, water hammer effect can be overcome. And here new terms are there when compared to the, you can compare here low head and medium head and high head. Here only, here extra one is 4 bay is available, 4 bay is available, and penstock is available. And here 4 bay, penstock, and also surge tank. So in this medium power plant, penstock 4 bays act as a surge tank in this medium head power plants. In the low head power plants, there is no 4 bay and penstock and uh, surge tank. So what are the points to be remember in the high head power plant? Nothing but high head power plants. Here, this mainly tunnel is extra tunnel is provided before the surge tank and connected to the penstock. So you can see that you can watch observe that tunnel before surge tank and penstock, and used steel pipes are used for the large capacity of water flow of the house. The penstock has the made with used steel. So in the absence of tank, surge tank, the water hammer can damage the this fixed gates. So already told you water hammer effect will be takes place because of the water hammer effect. That that water hammer can damage the fixed gates. So these are the classification of power plants based on head and construction and layout. So let us discuss the penstock and. So this is open or closed ducts which carries the water to the turbines. Nothing but by using the penstock, so water can be carried to turbine. Nothing but you can close or open that one. Nothing but open or closed conducts. Next one is it is made with reinforced concrete or steel, and to make this penstock we should use reinforced steel or reinforced or concrete steel we should use. And concrete penstocks are usually suitable for low head. Concrete concrete penstocks are used for low head, nothing less than 30 meters, and the steel used for more than 30 meters. And steel penstocks are designed for any head, nothing but less than 30 meters, more than 30 meters also you can use steel, but definitely this concrete one used for less than 30 meters height. And thickness of the penstock increases with the head and water pressure. Nothing but the thickness of the pipe is low, then due to the high pressure, and that pipes will get damaged, and so that that thickness of the pipe can be designed based on the head of the water and also water pressure. And the next one is surge tank. Surge tank, it overcomes the water hammer effect. Water hammer effect. So I'm repeatedly saying this water hammer effect. This is most important one. Water hammer effect is the effect when, for example, this is a surge tank, and the water will be releases like this. And this is a penstock, and this is the turbine. This is turbine. So when load suddenly decreases, when the load suddenly decreases, then what happens? So this speed of the turbine will be changes. When the load increases or decreases, speed of the turbine will be changes, decreases and increases. So to maintain the speed of the turbine constant, if the load increases, If the load increases, the speed of the turbine will be decreases. To maintain the constant speed of the turbine, the water to maintain the constant speed of the turbine, the water from the penstock will be releases to the turbine. In the similarly, if the load decreases, speed will be increases. So to maintain the constant speed of the turbine, the water will be sent back to the uh, reservoir, but the reservoir cannot uh, accept the changes, so that the whatever the when stock is available, whatever the water, this is generally this kept to empty. This much of water is available. When the speed will be increases, so excess water will be sent back to the this penstock. And when the speed decreases, and this excess water will be releases. When the speed increases, excess water will be sent back to the turbine, and the speed decreases, and that the water available in the that surge tank will be released to the turbine. Nothing but when the if you don't use such a tank, due to the sudden increasing of the load, decreasing of the load, that water will strongly hit the penstock. Nothing but strongly push back and pull back like that. That effect is nothing but water hammer effect that will takes place due to the changes of the load. So that your effect can be overcome by using the that surge tank. As the storage capacity of such tank is very less, so that it can release the water instantly, and it will store the water instantly, which will happen by the water hammer effect. Unlike a reservoir cannot release the water suddenly, cannot store the water suddenly, because of this water hammer effect. So that this problem can be overcome by using surge tank. The surge tank also is small reservoir which accept the sudden changes in water. So that water in this way we can overcome the water hammer effect. So if you take this surge tank, and this is additional storage nearer to the turbine, usually provide high head plants. So this is used only for high head power plants. For medium head power plant, 4 bay is used as a surge tank. Next one is, it is located near to the beginning of the penstock. So near to the beginning of the penstock, which is used. And as the load on the turbine decreases during the load rejection by the turbine, and the penstock, the surge tank provides space for holding the excess water, which I already discussed. Whenever the load decreases, that excess water can be stored in the surge tank. So that is nothing but a water hammer effect can be overcome. So surge tank overcome the water hammer effect, which I already discussed. So look at this one. This is a surge tank, a small tank like this. So this is all about the surge tank. Let us discuss the advantages of hydel power plants. First one is no fuel is required. To burn the fuel, separate fuel is not required. Only we should use the kinetic energy of the water to rotate the turbine. So separate fuel. There is no separate fuel used in this hydel power plants. Next one is no air pollution. Because of this water, there is no air pollution, because the natural water we are using, so that there is no pollution, and can easily work during the high uh, peak daily loads. So next one is I will discuss this one later, and it prevents the floods. So nothing but if you provide the dams across the uh, across any river, so the floods will be prevented. Nothing but sudden rising of the water and sudden falling of the water will be overcome by using the hydro power plants. So this is if you this is nothing but a high peak daily loads. Nothing but during if you take 24 hours duration, and this is morning time. This is up to noon, and this is up to evening, and this is night time. And so synchronization synchronization of this hydro power plants will take for synchronization hydro power plant generator takes a few minutes, nothing but if you stop any hydro power plant, again if you start the hydro power plant, it takes few minutes only, nothing but whenever the power needed in a peak time, that can be instantly utilize this hydro power plant for peak loads. For example, if you take thermal power plants generator, to make this thermal power plant generator in the synchronization, to make the synchronization of thermal power plant generation, it takes 2 to 3 hours time. So that 2 to 3 hours time, so that this thermal power plant cannot be used for instant load or peak loads. So because why it takes 2 to 3 hours time, because so to produce to make that actually the boiler temperature is approximately 540 degrees centigrade. So to get this 540 degrees centigrade, it takes a lot of time, and also you need to send the stream through the pipes, and you cannot send this 540 degrees temperature stream instantly, and you need to send the temperature slowly in a gradual manner, otherwise uneven expansion takes place. So to overcome all these problems, we need to gradually synchronize the thermal power plant or nuclear power plant generators, so that these power plants, thermal and nuclear power plants, cannot be used as a peak load or instant load demand. That's why these power plants are used as a base load power plants. Base load power plants. And this idle only used for peak load power plants during summer only. And during rainy season, it is used as a base load power plant, because floodgates or water is available, so that excess flood water can be utilized to produce the electricity continuously. And that's why this idle power plant used as a base load during rainy seasons, and we can overcome the power demand. And gas power plants or diesel power plants used as a peak load power plants in theaters, in cinema halls. If power loss and backup power used as a gas or diesel, and this backup is nothing but a peak load or instant load, such a power plants are called peak load power plants. This is all about the idle power plants.